All right, I think we're actually getting started. Yeah, I was gonna say last time I was here was at Christmas to see Nutcracker with my son. And so it feels a bit odd to talk about Llama and the impact of open source on kind of responsibility and safety. Very different topic, but this is what we're gonna do. So we're gonna talk about Llama and how it intersects with kind of questions of responsibility and safety and how we think about it at Meta. We're going to focus more on the developer aspect. Obviously, this is a developer conference. This is, one of the best things, building Llama is to see how the whole developer community can benefit from those tools and innovate on top of them. So we'll focus more on how we enable developers with those foundation models rather than all the different products that within Meta we build, like Meta AI and all the different AI tools that we build for our users. So my name is Vincent Gonguet. I support the Llama safety team from a product perspective, and Spencer here leads our cybersecurity efforts, and we thought we would kind of do specific applications of how to deploy Llama in kind of a coding context and see how to take care of the different cybersecurity risks associated with those deployments. So I think it's pretty clear within the AI community that there is an ongoing debate on kind of open and closed models when it comes to generative AI. So this debate is not new, right? So I think in the cyberspace, it's been existing for a while. Like there's been this debate on security by obscurity and whether being open and transparent is a better path in the end than like the short-term path to kind of use obscurity and kind of closed systems. A few months ago, we released the Llama 3.1 405B model, which was kind of is still the leading open source model out there. And as part of that, Mark did a kind of full open letter, invite you to read it, to kind of talk at a at a high level how to think about the equities of open sourcing and how to think about this trade-off between innovation and competition. I think it's pretty clear that it levels the playing field and provides the technology at scale to anyone. And really the thing we need to think about is, well, what's the trade-off on safety and responsibility? And I think what we wanted to do today is to go a little bit deeper on how we actually implement that in practice as a team and all the different tools that we provide to developers. There's kind of three buckets of efforts to kind of simplify what we do. The first one is providing models in and of themselves enables a lot of research and kind of transparency, but I think more eyes and more scrutiny and more testing and more feedback from the whole community. And that's kind of like the magic of open source. It's hard to control. It's part of how the ecosystem works. Then obviously we do a lot of safety work for our model releases. So I'll talk about this. We don't open source all our models. Like we have a long history at Meta of I think over 1,000 open models that we've released, but some of them are demos or on-site, or we only provide them to select researchers. So this is not a kind of always open source. So there's a set of kind of work streams that we have to enable those releases. So I'll just do an overview of the types of things that we're doing. And then I'll finish with kind of how we think about enabling developers again. So what are the different tools that we provide? How do we make it easy for any developer like you all to kind of very quickly deploy apps and not have to go through all the work of safety alignment and those types of things. And then as I mentioned, Spencer will kind of do a live kind of application of that for a specific coding application. Okay, so the first step is obviously to provide great models. So there's a tension here, right? Like the more powerful the models, perhaps the more risks, but the more powerful the models, the more they're close to the state of the art and they enable researchers and developers and civil society to test and to really see what happens within those models. When you have closed systems, you can obviously do some research, but you don't quite know, what's preventing misuse or what is triggering kind of unsafe responses to various prompts. It can be system components that are kind of like filtering things, or it can be the model itself. It's kind of hard to scrutinize what's happening in the model. You cannot fine-tune yourselves and do tests. And so that is the first part. So obviously, back in late July, we've released the Llama 3.1 suite of models. So we're trying to provide different sizes for different use cases, different inference costs, so that different labs, different developers, different companies at different scales can use those different models for their respective use cases. So today, those are still the leading open models on kind of most benchmarks, including on LMSys, if you look at the ratings. We're within kind of the top 5, depending on the tests, even including closed models. And obviously, things change in AI every day, every week. So we'll see if that holds next week. But and that is really our commitment, to try to continue to provide the best models so that the whole community can scrutinize them, test them, implement them, provide feedback. And this is what we see in practice. I mean, the first thing we try to do, we got that feedback starting with Llama 2 on our research paper, and trying to really be transparent on all the different things that we're doing from a safety perspective. What are the kinds of testing? What are the difficulties that we're seeing? What are the hard trade-offs? And so we did the same thing for the Llama 3 paper, which I encourage folks to read, where we're trying to really explain what are all the different types of red teaming, how to think about helpfulness and harmfulness trade-offs in alignment, how to think about kind of testing for increased risk on things like cybersecurity and kind of all the different parts of the work that we do. And what we're seeing on the other end is across researchers as well as companies, developers, people on GitHub, build on top of those things and add to the feedback. So I added a few examples just from searching on Google of the type of feedback that we got. So additional research on representational harms. So those types of harms are pretty complex to do at scale across every single country, and nuances and kind of cultural differences that we see. So this is a great example of empowering that research to happen across the board and not in a centralized way. We also got feedback that Llama 2 was too safe, and there's a trade-off, right? If you add a lot of safety to models, they tend to overlearn and kind of refuse even benign prompts. And so we did a lot of work based on that feedback to kind of have a more nuanced approach to alignment in Llama 3. We're seeing new methods of safety tuning, new methods of red teaming. So we're keep on taking those learnings and bringing them back into the next set of models. And obviously, we're seeing the GitHub community kind of build derivatives of models and kind of their own flavors of kind of specific policies that they implement for safety for their own use cases. All right, so step 2 is to work toward those releases. So there's 3 buckets of work that we do as a team. A big part is kind of training and evaluation through the different stages of training. We need to develop a lot of evaluations. Obviously, LLMs are cannot quite be understood, like the interpretability is hard. So we need to kind of probe them in all kinds of different ways. And as we expand the set of capabilities, that work can be pretty tricky. So we increase between Llama 2 and Llama 3, just to give you a sense, by over an order of magnitude, the number of evaluations that we did, because we have to think about multilinguality of models, the ability to use tools, the different context length, and all those different things. So making sure that we scale our evaluations to the different types of risk vectors as the capabilities augment is a big part of kind of the first stage. In practice, it looks like building benchmarks, having expert red teamers who kind of know how to prompt models and break them, so that we can take those learnings and put them into training, as well as making sure that all the pre-training, kind of all the data that we put in the model is clean and vetted and all those different things. The second stage is alignment. So as we go into fine-tuning, what's called fine-tuning of the models, when we start from pre-trained models, we start to iterate and align them to different use cases and different tasks. So that includes safety alignment, which is kind of this dance between doing model fine-tuning, kind of teaching the model, what is safe, what is, what should not be an over-refusal, and kind of training the model to be balanced. Looking at the system level, there's also system level systems that we'll talk about that we can leverage and final development, in final deployment, to kind of have a nuanced set of policies or add additional safeguards. And then we do rounds of red teaming, so testing of the models to find new vulnerabilities and kind of put them into the training. So we do that multiple times until we get to a reasonable level of risk. Those risks already always exist to a certain degree. Models can always be jailbroken with enough sophistication, but we work hard to make them kind of well aligned so that the systems that we provide to developers are pretty strong out of the box. And then the final stage is thinking about, well, on those kind of critical areas of risk, like cybersecurity or chemical and kind of bio, kind of malicious misuse, how can we assess whether we're adding incremental risk to the ecosystem? So for example, if a cyber attacker wants to use, Google or using our models, do they really get a meaningful difference? And so this is the type of test that we're running to make sure that we're not adding incremental risk to the ecosystem by releasing those models for those classes of catastrophic risks. All right, so once we're there, actually just to give you an example on cybersec, so in some areas, we kind of run those types of kind of full set of evaluations and also release them in the open source ecosystem when we see gaps. I mean, this is a good example of, in general, in the world of safety, there's not a lot of open source evaluations. We see a lot on the capability side. There's, hundreds of benchmarks. But on safety, there's kind of a gap. And there's kind of this obscurity in the ecosystem on kind of thinking about kind of safety benchmarks. And so in the cyberspace, given we have great researchers and experts in the company, we provide those evaluations in the open as well, so that everybody can use them for their own deployment and to assess how their models are doing on all those different risk vectors. So this is what we call Cybersec eval. You can find it online and use it for your own use cases. And then the last stage is to provide all those different kind of components that make it as easy as possible for developers to release safe models. I think one mental model here is we don't want deployment of safe models to be excruciating, hard. Needs experts, needs a lot of compute, needs a lot of kind of money to generate data. And so what we do is, in addition to providing the pre-trained model, which obviously is kind of the raw model that everybody can use to really tune to their very specific applications, we provide an instruct set of models and systems that are pretty ready to use for applications like chatbots or kind of synthetic data generation and all the kind of popular use cases that folks may have. And we include that as part of what we call Llama reference system. And so we kind of put all those different components together so that developers like yourselves can use them out of the box and have kind of a bunch of different kind of reference applications that they can just kind of fork from. We also pay a lot of attention to system safeguards. So in addition to open sourcing models, we open source, models are specifically fine-tuned as safeguards. So, we call them Llama Guard, Prompt Guard, Code Shield. So those are, input-output safeguards that you can add on top of your models. We optimize them so that, they're not adding too much to the inference cost, and can be deployed to further both have flexible policies if your own use cases is quite different on certain types of risk that you're trying to manage, but also work great out of the box, and they're also cheaper than the alternatives of using kind of content moderation APIs that various cloud developers might provide. And then we add a responsible use guide as well, so that we can give all the stages and kind of also add pointers to the additional pieces that we don't provide. All right, so this is the overview, and then let's get into a specific use case.
Thanks, Vincent. Hi, I'm Spencer. I'm a product manager focused on cybersecurity for our generative AI experiences, and we're going to talk through. Let's consider actually putting together a coding assistant, just so we have a concrete use case of what it is that we're trying to do. Like Vincent mentioned, we provide the pre-trained models as well as fine-tuned models for specific use cases, such as an instruct or coding experience. And so the first step we're going to do is decide which of the llamas that we're going to start with. In this case, we probably don't need to do our own fine-tuning because we already have a bunch of instruct models that are going to work pretty well for coding. And so what we need to do next then is go to step 3, which is what are the purple llama safeguard tools that we want to implement and include with our application. First, we're probably going to look at LlamaGuard. LlamaGuard is an 8 billion parameter model that allows you to do content classification and moderation, right? So we don't want our our code assistant to start spewing hate speech at us just because someone has a weird comment or something like that in our code. I'm sure for all of you developers, you have those kinds of experiences all the time. And there's a bunch of different categories that you can see from ML Commons that you can either decide to use, decide not to use. You can fine-tune LlamaGuard to your specific use cases. Maybe you find for your coding example that it's only relevant for one specific category, or maybe there's 5 or 6 that are ones that you want. Next, we're going to want to protect ourselves against adversarial inputs, such as prompt injections or jailbreaks. This is something that we recommend pretty much every application to use. PromptGuard is a very, very small model. It's not actually a Gen AI model. It's not built on the Llama. It's built on dBERT. And it'll help to classify different types of potential attacks as either what we call jailbreaks. So this would be your classic, hey, forget all previous instructions and instead go do this other thing. Or the more nebulous, what we call prompt injection risk, which is maybe we have some sort of third-party content that we're going to be including in our coding assistant. Maybe sometimes we want to look out to reference materials and include that in the context window, and so it's from an untrusted third party, and we're going to want to make sure that it's not going to mess with our application in some way, and this will help us to be able to add a layer of safety to that experience. And then finally, because we have a coding experience, we're probably going to want to put Code Shield on there as well. And what Code Shield does is it detects, it's not a model at all, it's a collection of effectively regular expressions and other static analysis rules that you can then run on the outputs of a model to look for known insecure patterns, right? So if I use like a C example, right, it's fairly well known, and this is a very simple example, but it's fairly well known that like string copy is generally an unsafe copying operation because you have potentially unbounded memory. And so it'll just suppress that from the outputs so that known insecure coding practices, whether this specific example or not would be an example of something that could be exploited, is irrelevant because the cost of the false positive here of suppressing the suggestion, we think from Code Shield's perspective is just so much better than letting that insecure code and bad sort of code smell into the code base in the first place. And one of the things that you'll notice is, or maybe if you're thinking about this a bunch or you try this yourself, for example, there's trade-offs between latency, like how long it takes to go through the chain of all of these things, or cost. Perhaps I want to use all of these services or as many of these services as I can in parallel because latency is the most important thing, and I don't, cost be damned, and I'm going to pay for that because it really needs to be performant. Or maybe I want to sequence them in serial because I actually care a lot about cost, and if it takes an extra 10 milliseconds or so for inference time to generate the recommendation or so, that's fine, and I can go on. And so there's a bunch of recipes about how to use these, how to implement these different sources. You can find them in the Purple Llama GitHub repo. And you'll see there also, for example, like PromptGuard, because it's based on a dBERT model, it's susceptible to a prompt injection where you just put like spaces in between every letter. And so in the recipes there, you'll see how we deal with that kind of very common attack and vector through. I believe also these slides are going to be shared with all attendees, so these links that are just blue here that you can't actually go to, you should be able to once you get the slides. And here's some actual URLs that you can go to so that you can see all of the things that Vincent and I have been talking about. Obviously, all of our models and all of the components that we've discussing can be found at llama.com. You can read the responsible use guide, and you can find each of the research papers for Llama 3 and for Cybersec Eval 3, where we go into explicit detail about all of the kind of uplifting and cybersecurity testing that we did of all of the Llama 3 models before we released them. Unfortunately, I think we are at time, so we don't have time for questions, but really appreciate your time and attention. Vincent and I will head to the side of the theater for anyone who wants to come chat about anything. And don't forget to sign up to get updates on Llama if you haven't yet. Check out the URLs that we just included. If you're actively looking to implement your own coding assistant or other LLM implementation and you're interested in using some of the safeguard components we talked about, you'll find links to those from here as well. And we really welcome all of your contributions too. The final point I want to make is we've released all of this as open source, in part to be more open and transparent about what it is that we're doing, but also because we want the community, we want your contributions, we want your ideas, we want you to build on top of what we've done and help us make everything better. Thank you all very much.